Graphing radical equations. Example 4. We'll start off with our xy plane. We have to undo this. Now, with the other examples, when we talk like x minus 5, we know that we would have positive 5 for a solution. In case you've forgotten how we're finding that, we're really just setting this equal to 0. 2 minus x equals 0. If I boot the x over, it means x is 2. So it's what creates a 0 under here. And so when I talk about my vertex, this is simply 2. Why? 2 minus 2, that's the x value, 2 gives me the 0. So I have an x value for my vertex that's 2, and I keep the value that's here, which is 3. When you look at this, you say, wait a second, we've been looking at x minus 2, x plus 4, x minus 7, whatever. When you switch the order of this, this tells me that it's going to open the other direction. Because the outside is positive, I am looking for the top part of that parabola that's been turned over on its side, but it will open to the left. That's what a negative x under a radical will do for you. So what I'll do, I'll locate the point 2, 3, 1, 2, 1, 2, 3. This is my vertex. Standard movements, as I just described. I need the top part of the parabola. So I can go up 1 to the left 1. Again, the reason why I'm going to the left is because of that negative x under the radical. It tells me to open leftward. Then I can go up 1, 2, and this should be left 1, 2, 3, 4 units from that vertex. So that would be here. And I'll go ahead and try to squeeze another one on there. So this would be 5, 6, 7, 8, 9. I go up 3 units and left 9. And now I'm simply going to connect those points. As I connect the points, I could then identify my domain and range. The domain, our collection of x values, it ends at 2, but it actually starts all the way over here, and it goes that way forever, so it starts at negative infinity. I cannot stress enough, please make sure that when you identify your interval notation for your domain and range that you're going least to greatest. The smallest x value I see on the graph would be negative infinity. So I use my parenthesis because I cannot contain infinity, and it runs all the way up to value 2. And I have value 2, I can touch value 2. So I can go 2 bracket. Range. The lowest value on my y-axis happens to be right here. It's 3. So I'll do a bracket, call it 3, and then this will go up forever. Remember that arrow on this says it goes forever, so it continues to go up this way, and so we'll say infinity. Let me get a parenthesis there. I'd like to do another example here. So let's do example number 5. And let's call this y equals, let's do negative radical 1 minus x minus 2. So we start off, as always, here's our xy plane. We need a vertex. To find the vertex, we have to undo this. So what value creates a 0 here if x were 1? So I have a vertex found at 1, negative 2. The value on the outside never changes. I locate 1, negative 2. That's my vertex. Now when I go to graph this one, I do notice that I have the negative on the outside of the radical, which means that I would be looking for the lower portion of the parabola that's been kicked on its side. And the negative x under the radical means that it will open to the left. So as I go to graph this, I will go down 1 unit, right 1 unit. There would be my first lattice point from the vertex. Then I go down 2 units, and I should go left 4 from the vertex. So here's 1, 2, 3, 4. That would be my second point. And really on these, I'm just trying to get 4 points on there. So I'll go down 1, 2, 3 units, and I should go left 9 from the vertex. So I'm at 4, 5, 6, 7, 8, 9 units from that vertex. And then I can put a point right there. So I connect the dots with a curve. Don't make those straight. They're not straight. They have curve to them. It's part of a parabola. And then you can easily identify the domain and the range. Domain. Our domain, the furthest left point that I can get, the leftmost point that I can get would be negative infinity, because this goes on forever. So I say my domain is negative infinity, and it runs all the way up to here, and that point we said was 1. So I'll say 1 bracket. I can contain 1. The range, we can go as low on the y-axis as you want to go, because this arrow is pointing this way. It goes this way forever, and you see it's going downward. So I would start at negative infinity for this, and it runs all the way up until that we reach this y value. It gets no larger than this y value, which happens to be negative 2. So I'll put the bracket there. And that gives us 5 examples now on how to graph radical equations. I think I'm going to do a couple more just to make sure that you got this, that you understand how to graph them. This concept is not terribly difficult, but it is something that you want to have in your back pocket. You want to be able to graph radical equations.